Consider the following statements in respect of two natural numbers p and q such that p is a prime number and q is a composite number. Now, this is one another classification of numbers. What is prime number and what is composite number? So prime number is that number which can be divisible, which can be divided only by that number only or one, right? So it doesn't have any other factors. So what are the examples? 19, 23, 3, 5. These are all prime numbers. Prime numbers have HCF as 1, right? Other than 1 and other than that number itself, it cannot be divided by any other number. So P and Q are such numbers that P is a prime number and Q is a composite number. And we have to check these conditions that P into Q can be, and it has said can be. So they have asked us the possibility. P into Q can be an odd number. Q by P can be a prime number. Now how to do this? So just take P and Q as numbers between 1 to 10. So P is a prime number and Q is a composite number, right? So between 1 to 2, what are the prime numbers? 2, 3, 5, 7. And what are the composite numbers? 4, 6, 8 and 9. So using these numbers, we can check the tests here. Tests given. So first test is P into Q can be an odd number. P into Q, let's check. Can it P into Q? Let's take P as 3 and Q as 9. So it gives me 27. So P into Q can be an odd number. Second test is Q by P can be a prime number. Q divided by P. Now again, let's check. 9 is Q and P can be 3. It gives me 3, which is a prime number. So Q by P can be a prime number. And P plus Q can be a prime number. P plus Q can be a prime number. So let's check. 2 plus 4. No, 3 plus 8. So 3 plus 8. 3 is P. 8 is Q. It gives me 11, which is a prime number. So all these three conditions are fulfilled here. That is why option answer will be 1, 2 and 3 all are correct. This was again asked in CSAT 2022. Interesting question. The sum of three consecutive integers is equal to their product. We have seen such type of question earlier, right? That says that some questions are recurring nature. That's why we are taking this series, so that at least the types of questions you will get familiar with, right? So whenever you see that question in exam, it will not be very alien to you. So the sum of three consecutive integers is equal to their product. How many such possibilities are there? Sum of three consecutive integers is equal to their product. What I told, whenever they say that product is equal to sum of numbers, at that time the numbers must be very smaller numbers. So one such pair is 1, 2, 3. Because their sum is 6, sum is and product is also 6. Now what are the other possibilities? They haven't said natural numbers, they have said integers. So we can take negative numbers also. -3, -2, -1. Sum will be -6, product will be -6. Right? So this pair also works here. So are there only two pairs or there is one more? So let's check. -1, 0 and 1. These are also consecutive integers. These are also consecutive integers. And their sum is 0 and their product is 0. Right? So there are three such pairs of consecutive integers which give us product and sum as same. Right? So just be careful. Just look at the wording right? Wording is very important. If you miss one condition, then your answer is going to be wrong. Next. When a certain number is multiplied by 7, the product entirely comprises ones only. When a certain number is multiplied by 7, the product consists of ones only, right? How many ones we don't know. But they have given 4 options. Now there are 2 ways. You can multiply every options by 7 and see which options give you all the ones. Or instead of multiplying, divide these ones by 7 till you get your answer, right? So if I divide, I don't know the number of ones. There can be more, there can be less. So just keep dividing. 7 ones are 7. It became 41. 7 fives are 35. So 6 is the carries. It became 61. 7 eights are 56. 56. So carries 5. 7 sevens are 49. Carries 2. It became 21. 7 threes are 21. So 15873 is that number. 15873 is that number, the desired number. So instead of multiplying all the 4 options, if you have started with option A, then you have to multiply all these options, right, to get the correct answer. But if you divide these 1111, you will get your answer instantly. So option number D is correct. How many zeros are there at the end of the following product? Till now we haven't used any formula. Till now we haven't used any particular method. These are all basic questions. Like here, just multiplication is given. You have to look at the example only. How many zeros are there at the end of the following product? So we know that if unit places are 0, then those many zeros are going to be in our answer. So 0, 0, 0, 0. So 6 zeros are there. If I remove those 6 zeros, the remaining expression will become 1 into 5 into 15 into 2 into 25 into 3 into 35 into 4 into 45 into 5 into 55 into 6. Because 6 zeros I have separated. So remaining expression will also give me some zeros. Let's check. Now see, 15 into 2 will be 30. So one more 0, right? 55 into 6, 6 into 5 is 30. So one more 0. And 24 into 4, it will give me 100. So 2 more zeros. So in total 6, 7, 8, 9, 10. So number of zeros this expression will be 10. Let XYZ be a 3-digit number where X plus Y plus Z is not a multiple of 3. So we have to choose XYZ such that sum of that digits must not be a multiple of 3. So take any number 1, 2, 5. So sum of these digits will be 5 plus 2, 7 plus 1, 8. 8 is not divisible by 3. So this expression works, or this example works. So this is XYZ. Then XYZ plus YZX plus ZXY is not divisible by. So XYZ is 125. YZX will be 251 and ZXY 512. So sum will be 888. So this sum we have to check is not divisible by which number. So is it divisible by 3? Let's check. 8 plus 8 plus 8, it will be 24. It is divisible by 3. So this whole number is divisible by 3. Same test is for 9. test for 9 is also add the digits and then divide by 9. Whether it is divisible or not, decide them. 8 plus 8 plus 8, 24. But 24 is not divisible by 9. That means this whole sum is not divisible by 9. So which option is correct? 9. Because we have to decide this sum is not divisible by. So by 9. There is no need to check other two options. There is no need to check other two options. Now next example is, let P, Q, R and S be natural numbers such that P minus 2016 is equal to Q plus 2017 is equal to R minus 2018 is equal to S plus 2019. So very important word here is natural numbers. If they haven't said natural numbers, it would have been very difficult to decide, right? Now, if they are natural numbers, that means all are positive numbers. All are positive numbers. All are positive integers. So, which number will be? Let's just check. Let's see what P and Q gives us, right? So P minus 2060. I am subtracting something from Q. I am subtracting something from P and adding something into Q. Then they are being equal. What does that tell me? That P is a bigger number. Because I am subtracting from it, then it is becoming equal to Q, which is adding something with it, right? So P is way bigger than Q, because if I take only these two expressions, it became P minus 2016 is equal to Q plus 2017. So this 2016 is going to be right side and it is going to be plus. So P is going to be Q plus 4033. So P is bigger than Q by 4033. So instead of doing this calculation also, we can tell that I'm subtracting from P and adding into Q, then they are becoming equal, right? So P is bigger than Q. So two bigger numbers here are P and R, because I'm subtracting from P as well as from R, right? So, but I'm subtracting a bigger number from R than P. I'm subtracting bigger number from R. So that number will be bigger, from which I am subtracting the bigger number. So R is going to be the biggest number amongst P, Q, R and S, right? So R is going to be the bigger number. How many 5-digit prime numbers can be obtained by using all the digits 1, 2, 3, 4 and 5 without repetition of digits? Now, this example can be from permutation combination also, because there we can, if this condition hasn't been given, and you are asked how many 5-digit numbers are possible using 1, 2, 3, 4 and 5, then answer would have been, if there are 5 distant digits, then answer would have been 5 factorial, right? So you have done 5 into 4 into 3 into 2 into 1, that is 120. But they have asked us how many prime numbers are possible here. So it is very complicated. That's why it is very easy, because you have to understand the first number that I can formulate is 1, 2, 3, 4, 5. But I can tell you that it is divisible by 5 because your unit place is 5. But if I return this number as 1, 2, 5, 4, 3, right? Then can I tell you whether it is a prime number or composite number? Yes. So there is a little twist. Just look at these digits and add them. Just see whether it comes under any test or not. So after adding all the digits, it gives me 1 plus 2 plus 3 plus 4 plus 5. It gives me addition as 15. And what does that tell me? That this number is divisible by 3, irrespective of any rearrangement. Because they have asked us to use all the digits. So when I use all the digits, the sum is going to be always 15. That means for any permutation, that number is going to be divisible by 3. Because their sum is 15. Sum of the digits is 15. So it is definitely going to be divisible by 3. That's why, how many 5-digit prime numbers can I form? 0. I cannot form any 5-digit number. Correct?